Hello, this is Jennifer Martinez. In this video, we're going to learn how to graph circles. So I start off with the definition of the standard equation of a circle. And here it is in a box with the center HK and the radius R. It's given by this formula. An example of circle centered at the origin, for example, this one is an example centered at the origin with radius 3. So the equation would be x squared plus y squared equals 9. That would make sense because the center is 0, 0 and the radius 3. So if you plug this into the formula, the h, and this would be the h and k, so the h is 0 and the k is 0 and the radius is 3. So you would get the x squared plus y squared equals 9. It makes sense logically as well, because if I use the Pythagorean theorem, just do any standard point here, we'll call it x comma y. That's the point on my graph. So this is the definition of x, this is the definition of y. You notice I have a right triangle. This would be the radius, which was 3. So you know by the Pythagorean theorem that x squared plus y squared equals 3 squared, which is the 9. So you can see that this formula makes sense. And then this would be just a horizontal shift, h to the right, and this would be a vertical shift of k up and down. So you can see it does make sense. Another way it makes sense is the distance formula. So let's look at this one for that. So first let me rewrite the formula. So just rewrote the formula. Remember, HK is the center. So this would be the H and the K. And this would be the radius. This would be the R. So if we just plug all that in, what would we get? We would get x minus the h, which is 2, plus y minus the k, which is 1, equals r squared, 2 squared, which is 4. And that would be the answer. Find the equation. If you want to see why it makes sense, well, I could use the distance formula for this. So let me do that again, what we did before. Let's just call this x comma y. And then let's this time, do it in red, do the distance formula, just to see if this formula makes sense. Here's the distance between 2 points, and I'm going to call this one my x2, y2, that's my second point, and this would be my first point. And you can actually derive the distance formula from the Pythagorean theorem. I'm just going to use this, and this is where we get the x2, which is x, minus the x1, which is 2, plus the y2, which is y, minus y1 is 1. And if you square both sides, oh, that distance right away is the radius. I forgot to write that. So let's erase that, write that at 2. And if you square both sides, you would get that to be a 4, and you would get rid of the square root, which is the answer I have over there. Okay. Next one. So now you can graph any equation in standard form. Because here, if we look at our formula, there's our formula up here, we can see, visualize what the h and the k is. So here, I can see that my h has to be the opposite sign, because it's x minus h is the formula. So it would be -1, and then the 3, well, we wouldn't have to take it there because we already have a -3, so it would just be 3. So it would be the opposite sign of both. It would be the center, that's the h and the k. And the radius, well, it's r squared here, so 2 squared makes the 4. So the radius, we know, is 2, because 2 squared is 4, or you can say the square root of 4. So now that we have that, we actually can graph that. Here's the answer down here. Let's make that a little bigger and move it over to the left. And you can see that the center is -1, 3, and the radius is 2. As you go 2 up, 2 over, 2 down, and the blue is the equation of my circle. Now, finally, if we don't have it in perfect standard form, right, how would we graph this one? How would we find the center of the radius? Notice it is not in the standard form, but it still has x squared plus y squared, right, which kind of looks like the first one. If I didn't have the 4x and 6y there, it looks like it probably is a circle because they're both squared. What you need to do is complete the square. So let's go ahead and scroll down and do that. To complete the square, I'm going to put a space with my x's because I want to complete the square with my x's, and a space with my y's because I want to complete the square with my y's. And I'll leave the 5 over here. Okay, so my next step is I'm going to find my magic number. How do you find the magic number? Do you remember that? Well, for the x's, we take 1/2 of the 4 and we square it. So that would be 2 squared, or 4. So what I want to do is add a 4 to both sides. Let's do the y's in a different color because we also have y's. If we took 1/2 of the -6 and square it, it would give me -3 squared, which is 9. I also could add a 9 to both sides. Let me draw a line there so we don't get messed up. So this becomes a x plus 2 squared. The y's become an x minus 3 times x squared. We just factor the x's, factor the y's. And the right side, if I just add these up, I get 18. So now we know the center is the opposite side of this, the x, the opposite side of the y, and the radius, well, it's not perfect, but I could still figure it out. It's the square root of 18, which, by the way, is about 4 point something. If you use your calculator, it's approximately 4.2. And now you can go ahead and graph the center of -2. You can sketch a graph -2, 3 is my center, and go approximately 4. We'll go down 1, 2, 3, 4 and a little bit. 1, 2, 3, 4 and a little bit. 1 on all 4 sides, and you can draw a circle around that. So there's my circle. So that gives me an approximate graph of that equation. Hope that helps.